semester, and even like the beginning of this semester, we were looking at linear functions, linear equations. And then for the last couple weeks, we've been looking at exponents, and we're starting to look at exponential functions. So I want to show you the difference between the two. The difference between a linear function, a linear relationship, and an exponential relationship, okay? And I think this is a really good way to like kind of see the difference. And it's a little creepy now, you know, considering the pandemic, but this is talking about a zombie outbreak, which actually spreads really similar to like what we're experiencing right now with COVID. But basically, we're going to look at two different strains of like a zombie virus. The first one, every day, the one original zombie gets to or is able to infect 2 people. So starting on the first day, there's just 1 zombie. If he infects 2 people the next day, how many zombies will there be? 3. Okay. And the other thing about this strain is the newly infected people cannot infect more people. Only the original zombie can infect people. Okay. So now he's going to infect 2 more people. So how many will there be now on the second day? Yeah, 5. And then 7. Okay. 9. And then 11. And yeah, 13. And then 15 and 17. So let's go ahead and graph what that looks like. So down here on the x-axis, we have the number of days. And it counts by 2s. So this first like major line is 2, 4, 6, 8, 10. And then on the y-axis, we have the number of zombies. And I think that's counting by 5s. Yeah, it's a little hard to read, but that's okay. So on the 0th day, on the starting point, there's just 1 zombie, right? So on my x, I start at 0, and at my y, I go up to 1. And then at my first day, I have 3. So I go count up to 1, 2, 3. On the second day, I'm at 5. On the third day, I'm at 7. On the fourth day, I'm at 9. So we should all be plotting these points. On the fifth day, I am at 11. On the sixth day, I'm at 13. The seventh day, I'm at 15. And on the 8th day, I'm at 17. Right? Okay, and what kind of shape does that make if we connect those lines? Or connect those points? Yeah, it's just a line, right? Line. Now let's go back and look at strain B. So in this strain, which is more, I guess, realistic, is each day every zombie infects 2 new people. So every single zombie infects 2 new people. So every zombie infects 2 new people. So if I start at 1, I think a picture kind of helps with this. Then after the first day, they're going to infect 2 more people. So how many will there be? 3. Okay, so we're at like the same level after the first day. But then at the second day, each zombie infects 2 more. So from each dot, we expand out and we infect 2 more. So now how many are there going to be? Yeah, there's going to be 3, 6, 9. Okay, and then after the 3rd day, again, we can keep drawing if we want. Infect 2 more on each one. So basically it's not looking so good, right? How many are there going to be at this level? After 3 days, how many will there be? There you go, 27. So what are we doing? How do we go from day to day? How are we calculating it? Not timing it by itself. What are you multiplying it by? By 3, right? So 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. I don't have my notes, so I don't remember. 81 times 3 is 243. 243 times 3 is 600 plus 120 plus 9. So 729, right? 729 times 3 is 2100. Thank you. What is it? 21? 2187. And what about 2187 times 3? And 61? Okay. So let's go ahead and graph that. So at the 0th day, so now, so still it's going to be days on the x-axis, number of zombies on the y-axis. Kind of hard to read, but it goes, I think it's still counting by 2s on the bottom on the x-axis, but then it's counting by 20s on the y-axis now. So at 0, there was 1 zombie, which is like down here. And at the first day, there's 3, which is just a teeny bit higher. And then at the 3rd day, now there's 27. Oh, I skipped 9, didn't I? 0, 1, 2. So we go up to 9, which is like right there. And then at the 3rd day, now we're at 27, which is up here somewhere. That's 20, 25, so 27 is like right there. And then at the 4th day, we're all the way up here at 81. And then by the 5th day, we're off the graph, right? So this is the difference between a linear relationship and an exponential relationship. A linear relationship has a constant slope. Exponential relationship goes faster and faster as time goes on. So this is a linear function and an exponential function. So in terms of like a virus spreading, and obviously we all saw this over the past year, you know, these exponential relationships are much harder to handle. They're much harder to control, right? They affect a lot more people than something like a linear relationship. Okay, so let's look at the pattern. So for the first strain, what is the pattern? How did we move from term to term? What did we have to do? We just added 2, exactly. Oops. Plus, why aren't you working? Plus 2, and then what did we do for the first strain B? We multiplied by 3. Exactly. Let's flip over to the next page. And just a reminder of what we were talking about last week. Can you try and guess what type of sequence an arithmetic or a geometric strain A is? You remember? Anybody? What type of sequence is strain A? Yeah, arithmetic. Arithmetic. And arithmetic sequences have a common difference, which means that we add the same number to go from term to term. So take a look at these sequences down here and see if you can find what the common difference is. So look at the sequence. So like this first one, we go 3, 5, 7, 9, 11, 13. Well, I look at that and I can see I'm adding 2 each time. So my common difference would be 2. How about the next one? Yeah. Minus 4. Minus 4. And then what about the next one? Yeah, add 10. So if I put a minus sign, that's telling me like to subtract. If I don't put any minus sign, then we know it's a positive number, and that just means that we're adding, right? Okay, so some like key points of arithmetic sequences. They are linear relationships. We add or subtract to go from term to term. And they have a common difference. And then strain B is going to be an example of what kind of sequence? Yeah, geometric. Shouldn't have put that in there. Geometric sequences have a, do you remember what they're called? It's a common what? Yeah, common multiplier or common ratio. We're going to use the term common ratio. But yeah, you can also think about it like a common multiplier. And then same thing, we look at these sequences and see if we can come up with the common ratio. So this first one, I go 3, 6, 12, 24, 48. You can tell I'm multiplying by 2 each time. 3 times 2 is 6, 6 times 2 is 12, so on. How about the next one? I'm going from -2 to -6, -6 to -8. What am I multiplying by? 3, yeah, 3. Okay, and then how about this one? I go 27 to 9, 9 to 3, 3 to 1, 1 to 1/3. What am I doing? Yeah, I'm dividing by 3. 27 divided by 3 equals 9, right? 9 divided by 3 equals 3. But we want to put this in terms of a multiplier. We want to multiply by something. So if I have 9 divided by 3, what's another way I could write that? Another way I could write that. Well, 3 times 3 is 9, right? But so we could write it like this, 9 over 3, right? That's okay? Yeah? This fraction line is just like the divide sign, right? Well, this is the same thing as 9 times 1 over 3. Okay, this would be 27 over 3 would be the same thing as 27 times 1 over 3. 3 divided by 3 is the same thing as 3 over 3, which is the same thing as 3 times 1 over 3. So what do we think our common ratio would be? What am I multiplying each one by? Yeah, 1/3, 1 over 3. So that's a really big concept, that when we're dividing by something, so if I take 24 and I divide by 2, that's the same thing as multiplying by the reciprocal of 2. So multiplying by 1 over 2, multiplying by 1/2. Okay, 100 divided by 4 is the same thing as 100 times 1 over 4. Okay, so every single division problem is also a multiplication problem if we just rearrange it a little bit. Okay, all right, let's go on to the next page. I gotta open this up. Give me a second. I think it was this. Okay. So there's a couple questions on there. First question, I think, says, what is a sequence? You guys should be able to answer that. That's on one of the pages I just handed back to you. So see if you can come up with a definition of the word sequence and write it down in your own words. Okay, what did you come up with? What's the definition of a sequence? Yeah, exactly. A progression. And then I'm going to add on to that today, saying that follow a particular pattern. So there's a pattern. Okay, let's look at these 3 different examples. So at the beginning we have just 1 dot, and then after 1 minute there's 3, and then after 2 minutes there's 3, 6, 9, and then after 3 minutes there's 9, 18, 27. So let's write those terms in the sequence. So it goes 1, 3, 9, 27. We looked at one just like this. How would we find the next term? What would we need to do? Yeah, multiply by 3. Multiply by 3. Okay. All right, this one, how many do we have at the beginning? Yeah, 40. 40, so that'll be our first term. Then how many are there after a minute? 20. And then 10. So how would we find the next term? Divide by 2. And we just said when I'm dividing by 2, what's this? How do I say that in terms of multiplication? Yeah, we multiply by 1 over 2, which is the same thing as dividing by 2. And now this last one, how many do we start with? 3, and then 6, and then 12, and then count again. 24. How do we find the next term? Yeah, multiply by 2. Multiply by 2. Exactly. Okay. Okay, so let's take 2 minutes and then answer these 2 questions yourself. What is the geometric sequence in your own words? Or you can copy down the definition we already wrote. And then what is a common ratio? What is a geometric sequence and what is a common ratio? So take a couple minutes and do that. When you're done with that, take a look at the swing problem. This is going to look really similar to what we were doing last week. And we'll go over it together in just another minute. Okay, so if we're looking at this problem, says Samantha's dad gives her a push on a swing. At the highest point, she's 5 feet off of the ground. And if he does not push her again, each progressive swing will be 85% of the height of the previous swing. So how would we find the height of the next 3 swings? And how would we find the height after the 10th swing? This is really similar to what we looked at last time. So the first swing, first one, A sub 1, that equals 5 feet. That's the initial, right? She starts at 5 feet. And then the next one will be 85%. 85% of 5 feet. How do we write 85% as a decimal? 0.85. And what does of always mean in a word problem? Yeah, multiply. We're going to do 0.85 times 5, or 5 times 0.85. And then for the third swing, we're going to take this number, 5 times 0.85, And we want to take 85% of that, which means we multiply by 0.85 again. Same thing here. We take this previous number, so that's 5 times 0.85 times 0.85 times 0.85, and we get how high she'll be after the fourth swing. Okay. So let's rewrite these using exponents. So if I have 3, I'm multiplying by 0.85 3 times, how would I write this? I'd write 5 times 0.85 cubed, exactly, 3 times. And what about this one? And then this one is just 5 times 0.85 to the 1. And then this one I can even write using exponents because it's 5 times 0.85 to the 0. So then let's look at the exponents. How do those exponents relate to the number of swings? The first swing, we have a 0 exponent. The second swing, we have a 1 exponent. The third swing, we have 2 exponent. Fourth swing, we have a 3 exponent. What's the relationship there? Yeah, exactly. The exponent is 1 less than the number of swings. So if I wanted to come up with how to find the height after the 10th swing, follow that same formula, right? I'd start with my initial value, that's 5. And then what would my exponent be on 0? Yeah, it'd be 1 less than 10, which is 9. Okay, let's go on. Next page. Okay, we can do this part really quick because we kind of already did it. So this first sequence we looked at, 1, 3, 9, 27. What was our common ratio there? Times 3, exactly. So our common ratio is 3. And so what would the next term be? Yes, but what's the next term in this first sequence? 81. Okay, and now, yeah, so what Ian said for this next one, the common ratio is 1/2, because we're dividing by 2. That's the same thing as multiplying by 1/2. And what would my next term be? And then this one, 3, 6, 12, 24. What's my common ratio? What am I multiplying by to go from term to term? 2. And so what would my next term be? Huh? Yeah, 48. Okay. So we're just going to take, let's see how many we can get through. So first type of problem we're going to look at is finding the next terms. So that's kind of what we did up here. First step we need to do is find the common ratio. We need to find out what we're multiplying by. And then we take that common ratio and we multiply it by the last term. And then we're able to find the next terms in the sequence. So to find the common ratio, we take one term and we divide it by the previous one. Okay, so 36 divided by its previous term is 108. Someone tell me Your calculator, 36 divided by 108 in fraction terms. Yeah, it's 0.3333 repeating. Do we know what that is as a fraction? No, but yes, no. Yeah, you could Google it. Here, let's put it in the calculator. So remember in Desmos, in the scientific calculator, so what did I say? 36 over, go away. What's this? Whoops. Go back. No. Clear. 36 divided by 108 gives us 0.33333 repeating. But if I click on that, it gives me the fraction. It's 1 over 3. But 3 over 10 comes out to be the same thing, I think. It's just 0.3. So it doesn't keep going on and on. Okay, so our fraction, our common ratio is going to be this fraction here. It's going to be 1 over 3. 1 over 3. So that means to find the next two numbers in my sequence, I multiply 1/3 times 36. So 36 times 1/3. That's the same thing as 36 over 3, which is, anybody? 36 over 3? 36 divided into 3 parts. 12. Good. So that's going to be my next one. And then I take that and I again multiply it by 1 over 3, which would give me 12 over 3, which is 4. So there are those next two numbers in my sequence. Okay, you guys give it a try. So first, find the common ratio. Take negative 75 and divide it by the previous term by negative 15. Negative 75 over negative 15. And then use that number to find the next three numbers in the sequence. So you'll probably use your calculator for that, unless you want to do long division by hand. Negative 75 over 15. And to find the common ratio, so I just chose 75 and 15. I could have also chosen 15 and negative 3. Could have done negative 15 divided by negative 3. And that should come out to be the same thing. Okay, so we always take 1 and divide by the previous one. The one just before it. Okay, so what did we get as our common ratio? 5. So then what would the next term be in my sequence? Yep, sounds right to me. And then? So we just take that 375 and multiply it by 5 again. Yep, negative 1875. Maybe you remember this trick. So, I can't hear. Yeah, so what you do is, so if I'm starting with negative 75 and I multiply it by 5 and I hit enter, and then I do answer times 0.5 or times 5 gives me negative 1875, and then I can just hit enter from then on, and it keeps growing. So my third term would be negative 9,375, and then negative 46,875, and then keeps going and going and going. Does that make sense? Yes? Okay. So there's some Khan Academy assignments that I just added, so you guys can pull those out right now. Let me show you which one to work on. So I assigned 4 of them, but they're not due until the end of class on Wednesday. So you guys have some time to work on it. And we're gonna finish working through this packet before we go, or before we'll finish working on it tomorrow. That's what I meant to say. No, I want you to, you can hand it in if you don't want to hold on to it, or you can take it home. Just make sure you bring it back tomorrow. Okay? So if you think you can't hold on to it until tomorrow, then turn it in and I'll hold on to it. And then find the assignment that says, let me go to classroom and go from there. So in classroom, there's the geometric sequences Khan practice assignment. This is going to be 20 points in total, so 5 points per assignment. And then go to this first one here, extend geometric sequences. And you're going to be doing exactly what we just did. So they give you a sequence, and you need to first find the common ratio, and then multiply that common ratio by the last number. Extend geometric sequences. In classroom, the assignment is geometric sequences Khan practice. Yeah. So first, find, this is like really bad. Maybe it'll look better on here. So first, this is like really bad. You guys know what to do? Yes? Do you want me to go over one? Yeah? Okay. So this one that I'm looking at, they give me 3 numbers in a sequence. First thing I need to do is find a common ratio. Find the common ratio, I take one number in my sequence. So let's say 18. Oh, It's just on a timer. It's okay. 18 and then divided by the previous term. So, can I show calculator? What is going on? Okay, I guess it won't let me, but 18 over 36. 18 divided by 36. Oh my gosh. It's not want to work with me today. Come on, 36. That equals 1/2. Okay, oh my goodness. Please just let me write a 2. There. So that means this is my common ratio, and that's what I multiply by 18 to get the next term. 1/2 times 18, that's 9. That'll be my answer. Okay. If you still have questions, let me know. We'll work on this until the end of class.